Welcome back to the Scotti-BYTE channel, and this is Scott. So one of my subscribers asked me recently if it was possible to migrate a Windows 11 HyperV VM over to LXD VM. And that prompted me to create this tutorial, which I entitle HyperV to LXD VM. So we're going to port a Windows 11 virtual machine from Microsoft Windows HyperV over to a LXD virtual machine. This involves first migrating the HyperV instance to a Linux KVM virtual machine. So watch my tutorial entitled KVM Virtual Machines 101 to learn how to install, configure, and use KVM. So once the HyperV VM is in KVM, then we perform some simple steps to port it over to a LXD VM. So let's go see how this is done. So here we are in my Windows 11 desktop, and I've launched HyperV Manager here, and I have a Windows 11 virtual machine with the name HyperV-Windows. I can go ahead and launch that machine and start it, and it will go ahead and boot up Windows 11 in a HyperV virtual machine. Now that it's booted up, I can go ahead and log in, and we should get the desktop in just a minute. This Windows 11 virtual machine has a few applications installed like VLC Media Player, Bitwarden, and the Brave browser, just as a point of reference. In order to migrate our HyperV virtual machine, you want to shut it down completely, and I performed a shutdown, and so therefore the state of it is shown as off. Over in the right-hand window here under Actions, you want to go over to Inspect Disk, and under Inspect Disk, it will show you all of the disks for your virtual machines, and they're located in a hidden folder called Program Data, and then Microsoft, and then Windows, and then Virtual Hard Disks. Now you may have more than one hard disk for your virtual machine or more than one file, and the reason you might have more than one file is because if you see another file name and it has a bunch of numbers off to the right hand side of it, that is really a checkpoint file or something that is used for snapshots and other metadata. But we don't really need that. We need the hard disk instance, which has the logo of a hard drive, and in this particular case, it's called HyperV Windows. Now this particular file, if you were to look at the file extension, it should have a file extension of .vhdx, which is the virtual disk type that virtual machines in HyperV use. So what we want to do is we want to copy that HyperV Windows disk image over to our Linux node. In this particular case, my Linux node happens to be running the CIFS file protocol, so I was able to do a drag and drop, and here I have my HyperV Windows down here on my Linux node, and you can see that it's a hard disk image and it's stored over there. You'll want to make sure that you have a way to copy that file over to your Linux machine. So here we are over on my Ubuntu desktop where I happen to have KVM running, and we have to convert our HyperV virtual machine first of all over to KVM to make a couple of changes in advance of making it into a LXD VM. So as you can see here, we have the hyperv-windows.vhxdx file, which is the image file for the disk for Windows 11 that came from HyperV. And here I'm popping up a terminal, and I'm going to run the QEMU utility called QEMU-img, and it's a convert. It says show the progress of the conversion while it's taking place. The input format is going to be VHDX because that's the source file, -O, and that's actually a dash capital O, which will be in the show notes. the output file is going to be QCOW2, and then we have the input file name and the output file name here, and we run the conversion process, and the conversion process creates the output file here actually fairly quickly. Now that we have the file converted, we can exit the terminal, and really we can exit the file manager as well, and we want to bring up the virtual machine manager. And again, you can reference my video on KVM Virtual Machines 101 to learn how to work with Virtual Machine Manager. So we're going to create a new virtual machine here, and we're going to say import an existing disk image. We're going to do a next. We're going to browse for this disk image, and I happen to have it in a file system space called HyperV, and the file we want is the QCOW2 image that we just converted. And I'm going to click on choose volume, and then down here at the bottom I'm going to type in Windows, and we're going to select Windows 11 since our HyperV virtual machine is Windows 11. I click forward. It chooses memory and CPU. I can certainly go set anything I want, keeping in mind that Windows 11 requires a minimum of 2 virtual CPUs and an absolute minimum of 4 gigs of memory. More is better. Here I've chosen 8 gigs of memory. So now I click forward, and it asks me for the name of my virtual machine. Just to kind of keep track of this, I'm going to call this thing HyperV-Windows, and then I'm going to click next or click finish, and it goes ahead and creates the virtual machine, and then it starts to boot up that virtual machine over here. So I can go ahead and click to full screen mode, and it should boot up completely and allow me to log in. So at this point, it means that we've ported our Windows 11 virtual machine from HyperV over to KVM. So the next step will be to port this virtual machine over to a LXD VM. So here I've headed over to the Vert IO Win, Vert IO Win package scripts web page. And if we scroll down to downloads, they have latest Vert IO Win guest tools. So you want to go ahead and click on that and go ahead and tell it to download. And once it finishes downloading, we'll go ahead and go over to the downloads directory. And we get into the downloads directory, we'll install the Vert IO tools. So I agree to the license terms, I do an install, I say yes, and here we're installing this on our KVM virtual machine, and we're just going to go ahead and let it pick all of the features, which I think is the default. So I click next and I click install. And I click finish. It's going to go ahead and install the SPICE drivers also, and it's going to update to the Red Hat virtual machine drivers. So now you can see that we have good video over here, and it's full screen, which is fantastic. So the other thing we want to take a look at is we want to go ahead and take a look at Device Manager here, just to get an idea of where we are. So if we go into Device Manager and we go look at computer, nothing fantastic here. We look at device or disk drives, and we have QEMU hard disk, and this is something that we're going to change, but it's not really obvious. Display adapters is now showing up as the Red Hat QXL controller, which is something that the LXD virtual machine will want to see. And then we can go down here and see IDE controllers is SATA AHCI controller, and then network adapters is going to be the Intel adapter, which it should update and go get the Red Hat adapters here shortly. And then finally, we're going to go down here and look at storage controllers. So right now we only have the Microsoft storage controller. So what we want to do next is we want to do a shutdown on this virtual machine. Once your virtual machine shuts down, we want to go over here to the information page, and we want to go down to Add Hardware. And in the Add Hardware section, we want to tell it that we want to install a new controller. In this particular case, we want to install a Vert IO SCSI controller. So we do a finish, and it installs that. So now we want to go ahead and boot our virtual machine back up, which is our HyperV Windows. We'll start it again. Go over here and open up the window. So now we're logged in here once again, and we went back to Device Manager, and the difference is you can see that the Red Hat Vert IO SCSI pass-through controller is now present, and this is going to be a requirement for our LXD VM in order to allow the system to boot as a LXD virtual machine. Now that we've verified that we have the Red Hat Vert IO storage controller loaded, we can go ahead and shut down this virtual machine, and for the most part we're really done with the virtual machine in KVM. But this whole time we've been making changes to it. It's actually been making changes in the folder where it found the original image, because that's where we loaded the KVM image. So if we go back here and CD into desktop/HyperV, which is where that's located, and we do an LS, here we are, and we've got our updated file. But if we do an ls-al, you can see that it has been updating pretty continuously over the period of time that we have been making our updates and changes to it. The next step here is going to be creating a LXD image so that we can import this thing as a container into LXD. So what we do in order to accomplish that is that we're going to do a nano on metadata.yaml. And in that metadata file, we're just going to go ahead and set up some pretty simple metadata. Here I'm just saying the architecture's x86-64. I just put some random number for creation date in there. It really doesn't matter, since it's just going to be the creation date for the image itself. And then the description is going to be HyperV Windows, and then the OS is going to be Windows, and the release is going to be Windows 11. So go ahead and save that out and exit the editor. And the next step that I want to do is, now that we have the YAML file, we have to put that YAML file in a tar file. And the reason for that is because the tar file is required as input for the LXD image command. So there we go, and now we have a tar file. So just as a review, if we do an ls-al, the original file that came over, the original disk image, was the VHXDX, and that was the image from the HyperV. We created that, we converted that to a QCOW2, and we created a KVM virtual machine with that. We went into that KVM virtual machine and we installed the drivers that we needed in order to be able to support LXD. And then we went in and we created a metadata file, and then we tarred that metadata file up. So now we're going to go ahead and create an image in LXD with this thing. So the command we want to use is LXD Image import that metadata.tar.gz and that hyper-v-windows.qcow2, and the alias we're going to give that is HyperV Windows Image. So now what this thing does is it goes off and imports that with the metadata, and now we'll have an image in our LXD server that we can use to create an actual LXD virtual machine with, and it should be that same Windows machine. Alright, so now the image is imported into LXD, and we need to create a new virtual machine with that image. So the command that we're going to use is LXC init HyperV Windows-image is the name of the image that we're using, and then we're calling the name of the virtual machine HyperV-Windows. We're setting boot.autostart equals to true, and we're giving it the default profile and also the bridge profile. And if you watch my video regarding LXD step-by-step, you'll learn about how to set up the bridge and how to set up LXD in general. And so when we do this, it goes ahead and initializes that virtual machine, but without actually starting it yet. At this point, I really do have a LXD virtual machine, and if I do a LXC list, you can see my other LXD virtual machines, but we have a new one here called HyperV Windows. It's still stopped because we haven't told it to start as of yet. And just for illustration purposes, I didn't really provide it all of the information. I could have on the command line, but I'm going to go ahead and now add the command LXC config set HyperV-Windows limits.cpu equals 4, which gives it 4 virtual CPUs, and limits.memory gives it 8 gigabytes of memory. Now that that's taken place, I can go ahead and start up my virtual machine, and I can do that with the simple LXC start command, and I can do a LXC start hyper-v-windows. Now, one thing that I want to point out to people is you're not going to be able to do a LXC list and see IPv4 and IPv6 addresses here, and that's because LXD is really built with the instrumentation for Linux in mind, and there's no internal instrumentation for Windows which will allow it to display that information back. So we can go ahead and connect to our LXD virtual machine at this point with either RDP if you had that enabled, or we can do the LXC console hyper-v-windows space -- type equals VGA, and that will go ahead and bring up the VGA window console for the remote viewer. And I'll go ahead and set that to full screen. We can go ahead and type in my password, and that'll go ahead and log in to this virtual machine. Since my virtual machine really didn't have a way to remember its resolution, I'm going to go ahead and do a right click and say display settings. And when display settings comes up, I'll click over here and go to 1920 by 1080 and say go ahead and keep the changes. And at this point, we have it up and running in full resolution. Now I'll go ahead and click here and go into Device Manager. And if we look at Device Manager and we look at disk drives, we're now going to see that the disk drive shows up as a QEMU, and then it says QEMU again, hard disk SCSI disk device. This is actually using the Vert IO driver that we set up. In display adapters, you can see it's using the Vert IO driver, and then down here in network adapters, it's using the Red Hat Vert IO Ethernet adapter as well. And then in storage controllers, since we added it in, it's of course using the Red Hat Vert IO SCSI pass-through, which is what our hard drive is actually using up here. It always shows up with a couple of PCI devices that are undefined. It doesn't seem to affect anything. Maybe some of the folks out there that are more Windows people might be able to identify what those are. I have not found that impacts the virtual machine or anything in it in any way. In any case, we have a full up and running virtual machine that was ported originally from HyperV over to a QEMU KVM environment, and then finally over to a LXD virtual machine. So in summary, you may want to port your HyperV Windows VM instances to LXD VMs in order to host them in Linux. LXD VMs provide the powerful LXD CLI with LXD profiles, images, and snapshots. The Red Hat Vert IO Windows drivers are key to migrating a Windows HyperV VM to a LXD VM. We migrated a Windows 11 HyperV VM to KVM, and then we migrated that to a LXD Image where it was possible to create a LXD VM from that LXD Image, which looked like our original HyperV VM in every way. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.